Welcome to Organic Chemistry Exams Prep. We are discussing currently the reactions of organometallic reagents, and specifically we are discussing the Gilman reagents and their reactions. So as we talked earlier, there are main three types of reactions of Gilman reagents. First of which is the conjugate addition of a carbon nucleophile. Second type of reactions are substitution reactions of alkyl halides, which is normal SN2 reactions. A third is substitution reactions of acyl halides. So this question 114 is third type of reaction. So in this question we need to find out the correct product of this following reaction. Now there are four choices, so we'll go one by one and eliminate the poor choices and then finalize the correct answer. So to answer this type of questions, first of all we need to see the reactant. So here we have our benzoyl chloride. This is our reactant, and the nature of this reactant is electrophilic because we can show the resonance, and once that happens the resonance form, so it becomes carbon becomes electrophilic. As we can see here, carbon gets a positive charge in this resonance form, therefore the carbon is electrophilic here, and our Gilman reagents are nucleophilic. So this is our Gilman reagent, lithium diethyl cuprate here. So this reaction is a substitution of the Cl group. So our nucleophile will attack at the carbonyl carbon, and the reactive intermediate forms, and then once it collapses the leaving group leaves. So it is a substitution, but this is a substitution at an acyl group. So let's see one by one the different answers and come to the conclusion of correct answer. So we have electrophilic carbon of the acyl halide, and this is our nucleophile. So overall the first step of this reaction is, so let's have a look on the mechanism of this reaction. So in this reaction the first step would be the nucleophile approaches the carbonyl carbon, so this carbon is the nucleophilic. So this nucleophile approaches the electrophilic carbon, and this pi bond between the carbon and oxygen breaks, and we form a tetrahedral intermediate where the oxygen gets a negative charge and we got the ethyl group connected to the carbon. Now in next step, this negative charge comes back, and a leaving group Cl, which is pretty good leaving group, it leaves and you form your product. Now, as we see, the correct answer here is D, which is the substitution of the chloride group by our ethyl nucleophile here. We can also see why other choices aren't correct, because if we see A, here the tag is shown by our nucleophile, which is alright, but the leaving group hasn't left and this is not stable, so that's why A is not the correct choice. Now if we look at B, once you form the tetrahedral intermediate, it collapses, so you do not get your OH here. In fact, the carbonyl group remains carbonyl, so B is not correct either. Now we see at option C. So in option C, basically we have shown the addition of the ethyl group twice, and in fact this is what happens in case of Grignard reagent. So if we had our Grignard reagent, which is RMGX, then that would give this type of reaction where addition of the alkyl part occurs twice on the carbonyl group. So that's why C is not correct. However, if we were to have a Grignard reagent, then C would be the right answer. Therefore, our correct answer is D. So we are going to see the Grignard reagents in next video. So we'll stop here. Thanks for watching.